Welcome to writing equations. First, we're going to write algebraic equations. Before, in Chapter 1, we were writing expressions. Now we're writing equations. Remember, the difference between an expression and equation is an expression does not have an equal sign and an equation does have an equal sign. The way we determine where the equal sign is by the word is. It can be written as, won't work there, okay, equals. Here's another one, is and is. That's where we put the equal sign. Just as a reminder, the word than, T-H-A-N, means you switch them. Otherwise, you write left to right. Let's take a look at these four examples. Letter A. 5 times the number A squared is 3 times the sum of B and C. And so we have 5 times a number A. 5 times a number A squared is 3 times the sum. This is when I know to write parentheses. The sum. This is when I know to write parentheses. And I'm looking for what I'm adding. I'm adding the sum of B and C. So I'm going to put 3 times the sum of B and C. And there we go. We don't have any than in there, so there's nothing to switch around. Okay, the next one. 9 times a number is subtracted from 95 equals 37. 9 times a number subtracted from 95 equals 37. Now, if you look at this problem, you need to look at it and you need to say to yourself, if I have 9a minus 95 equals 37, that says 95 is subtracted from 9a. But what the problem is, it's telling us 9 times a number is subtracted from 95. So we have to write the 95 first minus 9a equals 37. And that way it says 9 times a number is subtracted from 95. Okay, so go back and double check your work. The next one. 2 plus, I have 2 plus the quotient, I'm going to write as a fraction because it's also a division problem. Remember, the quotient's the answer to a division problem. So I have the quotient. Now what comes next tells me what's inside that quotient. The quotient of a number and 8, left to right, top to bottom, is the same as 16. So it would be 2 plus the quotient of a number and 8 is 16. Okay, the next one. 27 times k is h squared decreased by 9. Now, that's pretty straightforward. When you go back and look at it, it says decreased by 9, which means subtracted by 9. I can rewrite it and make it look prettier and push those two together and write 27k equals h squared minus 9. Okay, that makes it look, a little bit nicer. I like to rewrite the problems first, spreading it out, making sure I have everything exactly where I want it. Let's take a look at how to write a formula from a verbal sense. Number 1. The perimeter of a rectangle equals 2 times the length plus 2 times the width. They're going to use in the picture. Always draw a picture. I have length, so therefore this is my length. Width, and this is my width. Perimeter is the distance around an object, so it'd be your length plus width plus length plus width. Hence, I have 2 lengths and I have 2 widths. So even if you don't know that, let's take a look at what it tells us. The perimeter of a rectangle, P, equals 2 times the length, or 2L, plus 2 times the width, or 2W. And that's how you find the perimeter. Let's take a look at another one. This one's a little bit trickier. In a right triangle. So I'm going to go ahead, I'm going to draw a right triangle the best I can. Okay, seriously. Pretend that's a 90-degree angle. Okay, in a right triangle, the square of the measure of the hypotenuse. If you don't know, this is the hypotenuse, this line here, and we always label it C. It's directly across from the right angle, and our legs are A and B. So the square of the measure of the hypotenuse, so C squared, is equal to the sum, which means I'm going to add something, of the squares of the measures of the legs A and B. I'm going to square the legs, A and B, and it's equal to the square of the measure of the hypotenuse. Very good. Hello. Let's go ahead and translate equations into sentences. Remember, the difference between an equation and expression is that equations have equal signs. And for the equal signs, we're going to use the word is, or we can just say equals. Okay, we're going to write it the same way we would a verbal expression. The difference is it has an equation in it. Let's take a look at the first one. 3m, or 3 times m, plus is also used for addition, 5 equals 14. In this case, we wrote it out exactly the way it says. 3 times m plus 5 equals 14. Let's go ahead and take a look at number 2. Number 2 has a couple different variables. So we need to it's going to be a little bit trickier. We're adding the variables of w plus v, so we can't just say w plus v. We have to use whatever the words for the answers to an addition problem. And the answer to an addition problem is the sum. So we'll say the sum of w and v is the square, running out of room here, of y. You don't want to just come off and say y squared or is y squared. You could, I guess, but you can also say, the square of y, or you can say y squared. Number 3. Once again, straightforward. 13 put an I in there. Equals now here we can say the sum of, or we can say 13 equals 2, I wanted to say plus, we can say 2 plus 6 times t, or we can say, since we didn't say the sum of, we can say 2 plus the product of, they're going to make me write it out, 6 and t. So there are definitely different ways to write this, okay? Just make sure you include all the operations, all the numbers, and all the variables. The next one, how would you say that fraction? I would say a quarter, or, which for some reason cracks my students up every time I say quarter. Okay, so you can say a quarter. Most people would say 1/4 of a number. Now, I'm going to say number because I have one variable in this problem, and that's n. If I have more than one variable, I can't say a number because I don't know what variable, I don't know when it's changing. So 1/4 of a number plus 5. Probably should write it out. Your teachers are going to want you to write it out. Don't get lazy on me. Equals the number, because we already mentioned it, minus, that's a u, 7. Okay, we could say 1/4 of a number plus 5 equals the number minus 7. We could say, I spelled fourth wrong too. There. We could say 1/4 of n plus 5 equals the difference of n and 7. There's definitely a bunch of different ways to write it. Check with your teacher, make sure that it's the way he or she wants you to write it. Okay? I allow different ways to write it as long as they write the words out, and as long as they're including the correct operations, numbers, and variables. If I can rewrite it in the algebraic sense, and it comes out the same, then yeah, it's okay. Next one. How would you say that problem? 12 minus 2x equals -5. That's how most kids would read it. How can we write it verbally? We could say 12 minus, remember the answer to a minus sign is difference, so we could also use difference. 12 minus 2 times a number equals -5. Okay, and just write out the word negative and the 5. Okay, here's a little bit longer one. Remembered over here, where is it? The square of y. So we can say, and here I want to mention a. I can't use the number because I have more than one variable. I actually have 3 different variables, so I would have 3 different numbers. So let's start off with the square of a plus, because that's a plus sign. Anytime you have a number in front of a variable, it's that many times. So it would be 3 times 3 times b equals c. Remember, that's a fraction, so you can say divided or the quotient. I'm going to say c divided by 6. Write it out. There you go. Okay, good job. Now that you've had practice writing equations and writing the verbal expressions and writing formulas, let's, with the given information, write an entire word problem. We come up with the answer. They only give us a small amount. They do give us the equation. The equation is a plus 2 times the sum of a and 5 equals 46. Okay. A stands for Rachel's age. And then a plus 5 stands for Taryn's age. Notice that's right here. This box here is Taryn's age. Okay? So let's go ahead and write a problem. What do we know? We take a look at what we know. We know Taryn is 5 years older than Rachel, if Rachel is A. So we can say Taryn is 5 years older than Rachel. We can also say the sum of Rachel's age, okay? I can't find my cursor. Here we go. Okay. Here we have an addition problem. What are we adding? We're adding Rachel's age and twice Taryn's age. So we can say, using the addition sign right here, the sum, which is the answer to an addition problem, of Rachel's age and 2 times Aaron's age, or twice Taryn's age equals What does it equal? 46. Okay, based on that, what variable don't we know? We don't know how old Rachel is. How old is Rachel? That's the unknown. Okay, so basically we're writing the equation that's given to us in words, and then we're writing the question, which is, what is the unknown variable? So go back and look at it. Taryn's 5 years older than Rachel. The sum of Rachel's age and twice Taryn's age equals 46. How old, that says how of, how old is Rachel? Okay, let's take a look here. What's our variable? Our variable is F. What does F stand for? Cost of fries. So that's going to be our question. How much do the fries cost? Okay. How much do the fries cost? Okay. Let's just state a burger is $1.50 plus fries, which tells me this right here, and which I just included this right here. Okay, so I know how much do the fries cost, which is my variable. A burger is $1.50 more. Now, down to the nitty-gritty. Let's include everything. 4 times this right here, remember, is the cost of a burger. 4 times the cost of a burger minus the fries equals $8.25. So hence, how much are the fries? Very good.